Hello YouTube, thank you for watching. We are about to begin our first C++ tutorial in what is going to hopefully be a long-running and enlightening series of YouTube videos in which I will teach you how to use the C++ programming language to write code. We're going to get started today with the basic Hello World program. However, I'm going to try to give you a little bit more of a thorough introduction to what we're doing and why we're doing it when we write Hello World than most Hello World tutorials do. My voice is starting to go a little bit because I've had to record this video so many damn times now, because every time I pause my video recorder the program crashes, and for some stupid reason I keep hitting pause. Yeah, it's my own fault, but I should probably get a better video recorder. But let's move along from that. Hopefully at this point you already have an IDE installed on your computer. If you don't, I highly recommend it. Don't need it because I'm going to give you an alternative for how to follow through with most of these videos without using one. However, it really is a good idea to have one. It's an integrated development environment. It comes with a number of tools that you can use to write multiple pages of source code, compile them into projects. Yeah, they're awesome. I use Dev C++, as you can see right here. You want to make sure you get the version of Dev C++ or whatever compiler you use that's appropriate for your computer. I'm using 5.4.2 for Windows 8, but as you can see, I just got done running through this lesson for the millionth time. I just have to erase our classwork there. If you don't have a compiler, or you don't have an IDE, I recommend getting one. There are a ton of instructional videos on the internet on how to get one and put it on your computer and use it to write code. But if you don't, you can just go to this site. Actually, I'll just walk you through the whole thing of how to get there. Compileonline.com. Yeah, we'll leave this page. So you go to compileonline.com and you scroll over here and you click on C++ 11, which is the latest C++ standard. And you go right on ahead and delete all that stuff. But okay, so now you're ready to follow along. The button you're going to use is compile and execute when we're done writing this program, and your stuff will pop up over here. I'm going to use the good stuff. So the very first thing we're going to do when we're getting started writing our first C++ program is we're going to use a hashtag. We're not going to write hashtag big boobies. We're not going to write hashtag YOLO. We're actually going to write hashtag include, which is a much cooler hashtag. It serves a much greater purpose than any hashtag you've ever written before. The hashtag in the instance of writing C++ programs is what's going to be used to precede a preprocessor directive. The preprocessor is just part of the compiling process, which, as you know, or as you might not know, when we're writing a bunch of code, blah blah blah, blah blah blah, blah blah blah, this doesn't actually mean anything to your computer. The computer doesn't think in letters and semicolons and spaces and stuff like that. In fact, it doesn't even think in hashtags. So the preprocessor and the compiler go through and link a bunch of stuff together, convert things into binary or assembly language, things that are readable to your computer. And when we do this hashtag, we're giving that preprocessor an instruction on how to go about doing that. In our case, we're going to tell it to include something, and what we're telling it to include is Iostream. What is Iostream? Well, Iostream is a library. So when you're writing code, you might write a whole butt ton of it, but you certainly don't write out the explicit computer language instructions on how to do every single thing that you're actually going to do. There's a lot of functionality already built into the C++ programming language, and that is available to us in libraries. Every C++ compiler is required to have these libraries that are enclosed in these brackets. Anytime you see include followed by a statement in these brackets, it means you're using an included C++ standard library. Now, you might at one point see include quotation marks and then something .h. This something can literally be anything, it doesn't have to say something. And that means one of two things. Either this is a library that the programmer has created himself, because if I create my own library, I enclose it in these quotation marks, and I give it the .h file extension. Or it actually just might be a C++ source code from an older C++ standard, because this whole decision to use these little brackets to denote a standard and included C++ library. Oops, here I am typing what I'm thinking or what I'm saying. That's a fairly new standard. So that's what that means. We're telling our C++ preprocessor to include a library, and the library we're including is called Iostream. Iostream is a library which gives us some statements that allow us to interact with the console, or if you're a Mac user, the terminal. If you're a Linux user, I hope I don't have to explain what I'm talking about, because you should know a little something about computers. The console is that black box that you probably picture when you think about, programmers and computer hackers and people like that. You always imagine them using these stupid black boxes with the flashing white line. Yeah. So Iostream is a library which allows us to interface with that black box, and you're about to see how we're going to do that. But before we get to that point, we're going to have to type something also important using namespace std for standard semicolon. A lot just happened there. Using is a word that literally means what you think it means. It's going to tell the compiler that we're going to be using certain sections of code. And the code that we're going to be using is going to be living in what's called a namespace. And the particular namespace we're using is a standard one. Now, that gets kind of advanced, but using a little pseudocode here, I'm going to give you an idea of what the heck that means. A namespace is just a section of code that's used to differentiate between statements and functions and things like that that might actually have the same name at different parts in your code. So if you're writing a big program with a bunch of different files, you might run into this issue where you say, okay, let's say I'm going to write a piece of code and I'm going to call that code something. And then I write another piece of code 10 million lines later and it's also called something. And then I try to later, even later on, I'm about to get this program to run and I decide that I'm going to run something. However, it doesn't know which of these two somethings to use because they both have the same name. However, we can get around that if we declare a namespace. Namespace, let's call this one foo. And then I write something there, and then I've got this other something that I put under namespace bar. Okay. Now this still wouldn't work, and this is all pseudocode anyway. But even if it wasn't, this wouldn't work because I haven't told it which something to use. However, I could always just say using namespace foo. And there's only one version of something living inside the foo namespace. So my computer now knows what to do. It can differentiate between these two somethings because they're in different namespaces. And in this case, we're just going to use our standard namespace. And we're going to move on from that. That is really difficult to tackle for a beginner programmer. I hope I haven't lost you yet. But if I have, don't worry. You're going to come back here soon. Because now I'm going to type int main with a parentheses followed by bracket and enter. Okay, what did we just do there? Well, we just did the most important thing in C++ programming, and that is give our program an entry point. Programs must begin somewhere, and they must end somewhere. And in the case of C++, we call that starting point the main function. Now, just to give you a little bit of information on how functions look, and, well, actually, I should probably tell you what they do first, right? Functions just contain blocks of code, and you technically could write a gigantic C++ program that has no functions in it, and you would really run into some issues trying to get your, the program to figure out what the heck it's supposed to do next. You'd have to be using all these statements saying, hey, jump down to line 20, and then, when that's done, go back up here to line 4, and, whatever, follow. You get the idea. There's functions allow us to make our code kind of modular, and instead of saying go down to line 20, I could just create a bit of code and call it, my function, and just say, hey, run my function. And then wherever my function's at, it'll jump to that point, run the function, and go back to wherever it came from. And just for a little bit of FYI, whatever piece of code initiates, whatever function initiates another function is called the function caller. It's calling that function, making that function do something, and we're getting ahead of ourselves. So let's just run back up here and talk about how to declare functions. Well, the first thing we do is we give the function a return type, and then we give the function a name, and then we write some parameters, and then we get some brackets, and we type something in those brackets. Wow, that's some good stuff. That's a lot. Return type. Computers recognize types of data. They recognize integers, characters, series of characters called strings. When we get a bunch of characters together, we call those strings. They recognize all kinds of things. And when we declare a function, it's going to be called at some point and used. And when that function exits, we want it to give something back to the function which called it. In that case, we need to designate what type of stuff we're giving back to whoever called our function, and that's what the return type is. In our case of the main function, we're not you might have thought this said initiate. You might have thought that's what that stood for. That's what I did when I first started. I was like, initiate main. Like, oh, that's so cool. Well, actually, this is int for integer, which just means that when the main function exits, it gives an integer back to whoever started it. We give it a name. We give it the name main. And then we write some parentheses, and in those parentheses we put something called parameters, which are just instructions regarding the type of information that we can give to that function to use and manipulate and do stuff with. But we don't actually have any parameters for the main function. The main function doesn't always not have parameters. Matter of fact, when you started up your IDE, you might have seen something like this. You might have seen int argc and char argv. And this is just some nonsense that you can delete, because all it's doing is preparing your main function to accept command line arguments, which is way ahead of our time. We're not going to talk about that yet at all. So we've got a function here. We're calling it main because it's our entry point. It returns an integer to whoever calls it, and you're going to see who calls it in just a second. And now we're ready to write some code in here. But let's make this a little bit of a piece of standard code. We're going to write return because every function has to return something, right? Well, not every function, but every function exits. And when that exit statement, the way to leave the function, to end the function, is called return. Since we are returning something, let's return a 0. Alright. C++ best practice, standard sort of, is to end your main function with a return of 0. That's how you know it exited well. But just for fun, let me just prove to you that you can return any type of integer you want. Let's return 256. That's a random number that I just picked off the top of my head. Okay. Now at this point, we've broken down a lot of stuff. We know we've got a main function. We know that's the starting point. We know we've got an integer that it returns when it exits, whatever the hell that means. We know we're using a standard namespace, and we've given ourselves the ability to interact with our computer console, and you're probably getting pretty fed up with watching this video right now because you know what? This is starting to seem really boring. So let's do something fun. Type cout, followed by a space. Use spaces. If you're going to learn how to program for me, you're going to use spaces so that your code's legible. Space and a couple of these brackets, the less than symbols. And then do another space. Put a quotation mark. Write whatever you want right here. I'm going to write hello world. You know what? It's so boring. I'm going to write fuck yeah, because that's cool and hello world is not. Okay, and then we're going to put a semicolon because we've made a statement. All C++ statements end with a semicolon. Now before we get in there, what the heck we just did there, I want you to go have some fun and hit compile and run. Hopefully this works for you. If it doesn't, I'll tell you why, but hold on a second. Whoa, look at that! My computer just told me, fuck yeah. How often has your computer told you that? I mean, you might have looked it up on YouTube or something, but I mean from your computer, from the deep recesses of computer memory and binary digits flipping around inside of it, a console window pops up and says, fuck yeah. How often does that happen? Never. Now. It's the only time that's happened. Okay. That's cool. You might also notice that process exited with return value 256. That is from right there. I did that. I made it return 256 because the operating system called our main function. It started this program. It ran. And when the main function was ready to exit, it had to return something to whoever started it up. And it returned the number 256. And that was displayed to us. Now, we're never going to do that again. You are never, ever, ever going to return 256 from your main function. You're going to return 0. That's what you do, because I told you. Because it's the standard. So what do we do here? Well, cout. What the hell does that mean? Cout is from Iostream. Cout is a keyword which tells us to put out some sort of statement, some physical, like literally letters and numbers that you can look at to the console. This is a console output. That's what that means. And then we went ahead and put these two little things here, which whenever you put a cout statement, I just want you to remember to put those. I'm not going to get into why the heck that means that, because these are bitwise operators. They're just forget it. So this is part of the cout statement. Just look at it like that. When you put a cout, you put a space and then less than, less than. Then we went ahead and wrote something in quotations. This is actually called a string literal. Now, it's really hard to explain all this before we've talked about variables and such, but basically, a string is a series of characters and spaces that your computer recognizes the whole thing as one piece of stuff. You know, it's not actually looking at this as a bunch of individual letters. It's saying, hey, this is a whole thing here. This is a string of letters, okay? And your computer recognizes strings using the quotations. Literal, forget that I said that. Just forget that I used the term literal. Just for fun's sake, as opposed to a string, you could have just typed a single character. Characters are denoted by the single quotes. And if I run it like this, I'm gonna wait for it to compile. It just says A. And process exited with return value of 0, which is so comforting to see because that's what it's supposed to say. So we went ahead and just did that. We just wrote Hello World program. We learned what the hashtag means. It's a preprocessor directive. That we always want to use this Iostream library so that we can send stuff to our console. And for the record, I don't know if I already said this, but you're going to be using Iostream a lot in the beginning of your programming career because the console is the best thing to learn how to program with. You start trying to get into graphic user interfaces, API, stuff like that, you're just going to screw yourself over. Learn from the ground up, use your console. We learned that we're going to use our standard namespace to get our programming career started. We don't need to define our own namespaces yet. We learned how to declare the starting point for our program and define or clarify that it's going to return an integer when it exits. And then we learned how to use cout, which means console out, to print stuff to the console. And if you want to, you go ahead and have fun and you start, couting whatever the hell you want, experimenting with things. Although I'm going to warn you, don't do anything like this. I am stupid, because that won't work. Because, watch. Bunch of error statements. Yeah. Stupid was not declared in this scope. Expected, semicolon, warnings, That's bad. You could do this. That would work. Watch what happens. What? Oh, God, so stupid. I am stupid. Literally, I am stupid. That's why I put that, because I knew that I was going to do that. Ha! See? See what happens there? Yeah, that's fun stuff for you to play around with. And learn how to print stuff in the format that you would like to your console window. Because computers don't recognize the things you always expect them to recognize. Now, I'm getting kind of tired here. I'm joining on. I've made this video too many times. I've never done this part of the video before. Might make it more fun for you. But basically, the lesson I'm trying to teach you is that your computer does not recognize returns. Like if you just hit enter and you start something on a new line, your computer's like, what the hell is this doing? What does this mean? It recognizes statements on a single line unless there's no unless. Put things on single lines. It's okay if you're writing a bunch of code, like you're writing a super long statement like this, just a bunch of S's, okay, and it runs out of room. Sometimes, I forgot mine doesn't actually do that. Depending on what the heck you're using to code, it might just roll back around, and that is okay. But if you hit return to do that, nope, you just messed up. So, I am the great I am. I am Eric Valero, and I just taught you how to write a program. I almost forgot to tell the people whose window is closing right away that they can do this. This is going to hold your window open. So basically, the way we had this program written before was there was no instruction on what the console should do after the program gets done running, so it just closed itself because the console didn't see any reason to stay open before. My IDE and many of them actually include a built-in statement which holds the window open when the program is done running. But if yours doesn't do that, you need to explicitly tell it to. cn.get is a function which tells the console to wait for input from the user. And you actually see when I run it now, it's going to do something a little different. It is going to not give me all that return statement stuff. It's going to wait for me to enter something, which I'm just literally going to hit enter, and then it's going to say process exited with return value 0, and we're done. This honestly is bush league. This is beginner programming to have to use this cn.get. And the reason I say that is, first of all, when we're writing our programs in the future, our control flow should be set up such that when the main function's done executing stuff, the console window should not need to stay open. And furthermore, you might already have something in what's called your input stream, because that's what this is looking for. C input, console input. If there's something already in there for some reason, then even if you don't hit enter, it's just going to read whatever's left over floating in your input stream and decide to close the console window. So if you're getting ahead of yourself, like you haven't watched my other videos yet, maybe you haven't made them yet because this is my first one, and you're starting to do a bunch of programming and you're throwing cn.get every time to hold your window open at the end, then expect bugs, because it will happen unless your input stream was cleared, which honestly you can do what is it? I never use this, so I think it's cn.clear. Let's see. Yeah, cn.clear does it. So you might need to put those two statements together at the end, but expect to run into some issues. If you're getting ahead of yourself doing a bunch of programming and you need to find a way to hold your console window open, that might cause you problems. One thing you will never ever do is this. Do not do this. I don't even know what library this is in, so it's not going to work for me because I don't use this. This is a operating system specific command which forces your console window to stay open. It has huge overhead, meaning a whole bunch of stuff needs to happen for this statement to be able to execute, and you have to include, it's like windows.h or something stupid like that. Don't do that. Use cn.get, or be patient and wait until my next video comes out and you can learn some more about programming. So, thank you for watching. Sorry for getting a little distracted there at the end. I hope these videos are both entertaining and enlightening. They're certainly entertaining for me, doing all this very late at night, a million times in a row. And I look forward to doing the next one with you. Thanks, and put questions and such in the comments.